Okay, welcome everyone. This is the working group device management meeting from December 9th. My name is Patrick Oli. I'm going to be your host today again. John and Kevin are either not able to come at all or Kevin is going to be late, but we can start with CAP planning and discussions or whatever else people want to bring up in this meeting. Remember, this meeting falls under the CNCF Code of Conduct, which basically means be excellent to each other. And with that, well, let's see. Anyone on the call who wants to introduce themselves, raise some topics, questions? Now would be a good time before we dive into CAP planning, which is the only thing that I see on the agenda right now.
There's one thing I know. I think Ale might have put it in the wrong slot. Yeah, I'm here, by the way. I said I was going to
Okay.
not be here. Um,
You just wanted me
uh,
to host it, right? No,
yeah,
it's
that was
fine.
my cunning plan to make you host it. Yeah, no. The last thing that's in future meeting agenda, Ale actually wanted that in on the agenda today.
Okay,
But he can't be here for 30 minutes. So, if we can just delay it till then.
Okay. Yeah, I went through our excellent table and also scratch or search my memory for things that I remember about these things and what currently seems to be important. And what I came up with is basically taking the things that are also on the top of the list of this table, and I think we should try to move forward. So basically, uh, my personal, it's certainly like a little bit subjective. Marlo, I see you had it up. Let me just finish that, and then you can go. So this is primarily focusing on things that we have already in flight. I would like to finish a few things or be sure that we finish them before we start more things, but I'm sure people will have other things that we want to push, and that's fine. We just need to figure out whether there are sufficient reviewers for other new things. So what I have right now is, because everyone wants it, extended resources to beta. A lot of work went into that in the past release. We didn't quite make it to beta because too many new changes, but hopefully we now have everything in and people can try it out in 1.35 and give us feedback so that we can confidently move to beta. Partitionable devices, device taints are all in the same stage. They should be feature complete in 1.35. They should work. They should be ready for beta. So the remaining work actually shouldn't be too much. And the same is true for consumable capacity. So we just need to verify the beta criteria and then we can graduate them. And graduation should be mostly automatic, just the API changes. Extended resources perhaps is an exception. I see some bugs filed against it. Some things are open, but bug fixes are still okay when preparing for beta. Yeah. I'm not sure whether Antonio is here. He wanted to move resource claim status forward. There is a question with SIGAuth around permissions. The conceptual problem is that we now expect the DRA driver running on the node to have write access to a resource claim status. And that is potentially intrusive if that node gets compromised, the DRA driver is compromised, and they get access to all resource claims in the cluster. That's not good from a security perspective. So the open PR that Antonio already created for 1.35 is about doing things in admission. I think it's admission phase in the API server, bespoke solution for resource claim status to limit access for the driver to the node. And there's an open discussion whether that is the right approach, but I think this PR is a blocker for it to move to beta, to GA, and I'm not even sure whether we can go GA if that's just landing in 1.36. continuing my list, admin access, prioritized list, they both have been in beta. I think we can graduate to stable. No major work needed as far as I know. Binding conditions. Yep.
Sorry, I have a question there. From what I remember, admin access was actually ready to go to stable in the last release, but we didn't do it, and I don't remember why. Is that because of adoption or?
Because of adoption. There is one thing that DRA drivers need to do to support it. So DRA drivers should have a check whether a resource claim has already been prepared. It's not required. We can't enforce that, but it's one of our recommendations to prevent unintended reuse of devices if something goes wrong. So DRA drivers in the node prepare resources are our last line of defense against catching mistakes that can happen if users say do force delete of pods and whatever not. They can do that. They can create situations where a device that is still considered in use on the node is getting allocated again by the control plane. And we want the DRA drivers to catch that.
Mm-hmm.
And if they are then unaware of admin access, that code should reject admin access. So DRA drivers have to support admin access if they allow concurrent access. And that's what we haven't really implemented. We don't have it in the example driver, for example. And also in real world drivers, we probably need to check that it works. I've been told by my Intel colleagues that it works. So that might be one example of something where it has been done, but I haven't double checked.
Got it. Yeah, I don't think we do that. I need to double check. We have someone internally that was at least testing the admin access, and I told them to make sure that the DRA driver is double checking devices not being, doubly allocated because of race conditions. But I don't think we did this extra check for the admin access piece. Okay. Yep.
Prioritized list is a bit simpler. That's, I think, entirely on the server, on the control plane side. So that's just a matter of, moving forward with it. Next on the list, binding conditions. So we still have the conceptual problem or the use case problem with it, that what Fujitsu is doing with composable disaggregated infrastructure is using this feature, but it's using it so that the normal happy path where binding just gets delayed never gets really exercised. So the feature is used, but not in the way how it was designed, and that's a bit awkward. The current thinking is that NVIDIA compute domains would benefit from this feature because they also need to delay pod startup while preparing the node. And I don't think we have relevant people from Fujitsu on the call today, but I think there is an agreement. I know Kevin and we talked about it, that if they are willing to work on a PR for the open source NVIDIA driver that makes NVIDIA compute domains use this feature, and it works even as a prototype or as an alpha feature in a PR, then that would unblock binding conditions. And because it showcases that this feature is useful as designed with something using the happy path.
Yep. We're aligned there. Yep.
Yep. Okay. So we just need to tell Fujitsu. I think we were asking somewhere, but we need to find that
I
thread
need to
again.
respond to that. I'll do it right now, actually, in the background.
Yeah. Okay. Yeah, and then let me go back to the table. What we have pending. Well, Morten is not on the call. I think list attributes, it has a cap pending. That would be a new thing. Resourceless mixin keeps getting pushed out. Reserved for workloads is being discussed, but no cap written yet, and we are just still looking at conceptual questions around it. Native resource requests, Praveen, I think, is driving that, but yeah, we need to see whether we can get a cap together that is complete enough that we can say we want to do it now. And I guess, Marlo, you have other things that you would like to see implemented. right?
Really just one. I'm putting a link in the chat, which is 5717, which has to do with the number of devices per pod is currently much lower. And if we're talking about CPU stuff, we're going to want to be able to assign more than the 32.
It should be 256. Didn't we update a while ago?
Is this per pod or per slice? 256, I thought was the per slice.
Ah, that's what you're saying. Got it. Yeah. I thought
Yeah,
you were saying how many pods could reference the resource claim. Sorry.
no.
Yeah.
Um, I'm a bit confused too what the number of devices per pod is, because we don't reference devices in a pod. We reference resource claims in a pod.
Sure, resource claims. I can update that.
Yeah, okay.
I'm thinking in terms of devices because I'm talking specifically about CPU, but it could be anything else.
Yeah, and resource claim could be multiple devices. So you don't have to have one resource claim per CPU. I'm not sure whether that helps.
It
I'm
doesn't
just
really
saying.
help because when you're
Yeah,
talking
okay.
about telco or HPC, you want to enumerate in some cases.
But you can have multiple requests in a resource claim and then reference individual requests for containers in one shared resource claim. So you're not forced to make all devices in a resource claim available in all containers.
Yeah.
So I think we need to
We need to
clarify a
talk
bit
about it.
more. Yeah, we
Yeah.
need to figure out what you are trying to do. The other problem with these limits is that, well, if we just raise them, does the whole allocation process still work with sufficient performance for the use case that just does things at a scale where the DRA wasn't designed for? Well,
Yeah, I
that's
understand.
the other question that we need to look into.
Yeah, well, it's why is that restriction there?
We have to have limits like that
Yeah.
for slices, and current limits are fairly arbitrary. We just picked something that seemed reasonable based on the use cases that we had in mind originally, which was GPUs mostly, and yeah, that's what we have. It's not set in stone. Changing it is a bit needs to be done carefully, but we can. But we need to understand why and what will be the usage if we change the limits. Is that still something that we can support? Morten is here. Good.
Yeah, no, I was going to say, I think the same thing that Patrick mentioned earlier, like we need to understand the full use cases because we had discussion around this at KubeCon and some of the use cases seem like they could perform very poorly on the edge cases with the current allocation algorithm. So we should understand the full, how we plan to use them and do some estimates at least on how they will perform. So.
Yeah, we're using a different scheduler so that we wouldn't have the same issues necessarily.
The problem is that if we raise the limits and we allow users to specify something that doesn't perform well, we need to protect against that in the current scheduler. And we have some protections. We have cell evaluation timeouts. I think we have an overall limit for how long allocation is allowed, but it's fairly generous. And if we end up with a situation where every single pod on all nodes runs into that timeout, it will still impact the scheduling performance.
Mm-hmm.
Those pods fail, but also all the other pods get delayed because the scheduler can only do one pod at a time. So we need to think about that in the context also of what happens if someone does that with the core Kubernetes scheduler, not just, well, let's raise the limit so that some other scheduler can do something intelligent.
Yeah, I understand.
Perhaps the answer is that I don't know. Perhaps some configurable admission policy, but that raises other questions like if a cluster gets deployed out of a box, what is the default limit? And even if you run additional schedulers, do we know that the other scheduler is always handling the pods, or do we still have a mixture of some things where it could blow up in the normal scheduler? Anyway, let's keep that issue
Or
in
can you do
mind.
this
And
restriction per node or something?
yeah, it's in the request API, so you basically need to make a decision before you even know for which node you are going to consider that for.
Yeah.
So yeah, it's tricky.
Okay.
Morten, do you want to try for resource slice mixins in 136? I think it's listed here as alpha.
Yeah, I think we should think about what it looks like. I think we have it's been like the second time we think maybe we should rethink our plans for it, but it might be worth looking at enough to figure out if the current approach, at least that the cap was merged, I think. But yeah, we should figure out if that's viable or if we should go back to the drawing board again.
Yeah. Okay. Was the cap merged with the revised approach, or is it the final one? I know we had more discussions on how to do it.
Yeah, I don't remember exactly because for 134 we merged the cap and the code was almost ready, but some questions came up, and since then we have other thoughts on how this should look like. So
yeah, our limitation for the overall size changed, I think, and that might not be in the cap yet.
Yeah.
The one-off at the resource slice level, I think that may be missing.
Yeah, but I think
did
also
it. Sorry, go ahead.
I was going to say that the way we thought about it, where we have multiple types of mixins, I think at least me and John has talked about like if that's the right way. If it's as we add new features, it seems like the number of mixins sort of could grow in a way that would be weird and unsustainable. And maybe we should think about something that looks more like device shapes.
Okay. So. Yeah, maybe.
This is back to this question again from 2 years ago. Yeah.
Yeah, Peter, I see you have your hand up.
Yeah, I'm curious. There was formerly the dependency of mixins for partitionable devices. Is that still now with the new partitionable devices approach? Do we still feel like that dependency exists? I see that partitionable devices is aimed for beta, and at Red Hat we're really excited for that. So just wondering, hoping that resource slice mixins won't slow that down.
It's not functionally required. It just could make resource slices smaller. So it's an optimization to present it in a more compact format.
Yeah, I think his question though is if we would block graduation of the core partitionable devices feature. I think the answer is no.
No, I don't think we should, because it works. It's functionally complete. It does what it's designed to do.
Great. Yeah, awesome. Thank you.
Yeah. If the size of the current partitionable resource slices is too large in practice, that might be a problem. That's where we need user feedback from someone who is using it for a real DRA driver. And I guess I'm looking to Kevin here again. So we need to hear that this works.
It's been sufficient for MIG. It's been sufficient for MIG so far, but as we start to do more types of partitioning, that's when it might get questionable.
Yeah.
We did change the limit like for device taint, so it's only 64 devices, which makes the worst case less challenging with partitionable. And so, yeah.
Yeah, I remember saying that. Yeah, I'd say we're fine for now for graduating this in the next release. and we should revisit mixins and/or device shapes or whatever we want to do for a follow-up.
Okay. Well, my suggestion is that we do have one Slack thread on our Slack channel about each of these topics to discuss whether they are ready for graduation. And that's where we can collect feedback and use that as reference. This is a question that has come up a few times now for different features. How do we collect feedback? And I think doing it on Slack works well enough for me. We could also do a Google Doc, but I don't know. I'm fine with just a Slack thread. I don't hear no disagreement. Okay, that's good. So no one has really added anything, but it's certainly still open. I guess if people show up with a cap, we won't say no, or we'll not say no immediately. But getting some heads up would be nice, because we need to be cautious about our reviewer bandwidth. In particular, SIG scheduling is planning some key or conceptual changes themselves, so they are going to be busy again. Well, that's just a caution. Not sure whether we have Ale here yet. Jack, you are here. Shall we move yours up? And now I broke the formatting. Yeah, let's do the even more editing errors. AI conformance, topology awareness. Jack, do you want to talk about that?
Yeah, sure. Two points. One, I'd love for John B to weigh in on this, so I'll probably just speak to the detail point at a high level. So this is a potentially new AI conformance requirement that's going to define how we would recommend folks expose hardware topology via DRA. So I know that Laura L is working on a dedicated topology project/driver. I was curious if folks in this community had any thoughts about evolving the cloud provider projects themselves, like Cloud Node Manager, to expose cloud provider specific, like environmental specific topology metadata to a well-known DRA API. So maybe we would define something in a resource slice. So I don't want to go into too much detail about this sort of hypothesis, but something to think about. And open to the group. If anybody has any specific ideas about the right way, do we have like an opinion about the right way to expose environmental specific hardware topology using DRA?
We've only identified two cases. PCI Node, I think, was the first one, and PCI root. PCI root was the first one, and now just the other day something was merged about a bit more relaxed PCI. Well, again, PCI
Bus.
topology.
It's the bus. It's
Bus,
the PCI
yeah, the
bus.
bus.
Yeah, but I think what Jack's getting at, Jack's getting at vendor specific or platform specific.
Okay.
I would say more
Yeah.
platform specific. So think of like data center, hyperscaler specific. So how do we standardize that? How do we produce a conformance requirement that says if you serve a Kubernetes platform that's AI conformant, then you publish your environmental topology to a well-known location? That's the sort of like high-level conversation.
Yeah.
Yeah, we had talks with John early on about this because GKE had a similar desire, but I don't remember where those talks went. I think it just got tabled as we'll get to this eventually. I don't know if you remember anything more, Patrick.
No, I don't. The problem always is that in tree our abilities to standardize are limited. It is something that has to work across clouds, across vendors, and that's hard. And just having a place to store information without specifying what it is something that doesn't sit well with the Kubernetes API reviewers. So building in escape hatches, that did not fly, for example, for health information in the device taint API. I had a raw extension there for storing arbitrary data, and I got objections from the API reviewers because there was no in-tree user of that information. It would have to be a CRD, and then it's entirely vendor specific again.
Yeah, but I would picture this being a property of something you would implement in the underlying DRA driver. It wouldn't be something that would need to be in tree other than maybe a helper library. The same way we have a helper library for adding the PCIe root if you have it. If there was a way to read a file from the file system that had these vendor specific attributes that you could add to different devices or something like that, and we build a helper library for that everyone could use in some way.
So and then it becomes device attributes that get published by the DRA driver. The node architect role is that I remember that discussion. That's how John describes it. Yeah. I don't know
Kevin,
whether
you're describing a DRA
whether
driver that would be like a environmental DRA driver, like AWS DRA driver or something like that.
Well,
yeah,
no,
or
the idea was
that, or
the
it would be, yeah. I was going to. The idea was that that your DRA driver could, without imagine there's not a helper library, right? Any DRA driver that exists could read a file from the file system that was vendor specific, or sorry, platform specific, and it would integrate whatever attributes. I don't know what the spec for this file would look like, but it would somehow be able to read that, parse it, and know how to add platform specific attributes to all of the devices that it's advertising.
I see. So we essentially we move this forward by making a new DRA driver standard, and then we promote that within the DRA driver ecosystem. That like you always look for /init/ whatever the well-known location might be, and then just hoist that information to a well-known flexible interface so that you get that. I see. Okay, I like that we're thinking about alternate options here. Yeah.
Yeah, I don't know if that would be sufficient for what you described in terms of actually being able to, advertise the types of network topologies or whatever that you wanted to be able to, show. But for certain things, it definitely makes a lot of sense, I think.
Yeah, well, I mean, I think it takes some of the burden, just in terms of fulfilling a DRA interface. The DRA drivers are already doing that. So it is a nice distribution of labor in terms of like, okay, I'm a cloud provider. I know I just need to connect to my IMDS like endpoint and put some information in a flexible file location, well-known file location in just a super generic key value type way, and that the DRA driver will scoop that up for me for free and make a node association, like it'll find the right resource slice or resource slices associated with that node to publish that topology.
Yeah.
I mean, it's really an extension. Like various providers are doing this already, so that the IMDS flow. I'm sorry if IMDS is confusing to folks from Azure. I know it's an Azure AWS thing, so folks might not know what I'm talking about. But some environmental specific endpoint that then publishes node labels. That's a standard pattern that already exists. So if you build a Kubernetes cluster in a platform and you enable some specific environmental feature, it's super common for you to see on your nodes that come up in that cluster various environmental specific labels. So the idea here in AI conformance is that we want to standardize that with DRA and provide that.
Yeah, I think we would accomplish something like that with like we were saying, an in-tree library that knows how to read this file, and that every DRA driver could opt into vendoring in that library and making calls to it to be able to read whatever format is in, and then apply those attributes to the different devices that it's advertising. So I could imagine the file might say like, any GPU, I don't know how you would format it exactly, but every GPU should have this extra attribute on it or something like that.
Yeah.
Yeah.
Okay, cool. I'll take notes about that suggestion, and then I'll reach out to John B offline. The other meta point I wanted to make is that I've been attending these AI conformance meetings regularly as a SIG autoscaling stakeholder. And if anybody in this community would want to be there instead of having me wrangle for device management, because how it works now is very often something will come up around DRA and the folks are like, we need device management to give a thumbs up. So I'm happy to continue wrangling and just bring those concerns back so that folks don't have to go to another meeting, or you're welcome to go to these meetings.
Yeah, I started going early on, and then I now have a conflict, given that it's
Cool.
at
I'll just
7
keep
p.m.
wrangling.
7
Let me know.
p.m. in my time zone. Yeah.
Yeah.
Yeah. Great.
I'm not. I'm now just looking at the thing that you call out here, and if I look at just what I have on the screen right now, where they say in the device class create objects with topology attributes, my first thought is, well, that's not how it currently works. How can they standardize a certain behavior that isn't portable? And are they now standardizing in the conformance requirement that requires NVLink is a thing? I'm wondering. Yeah, Kevin?
I'm assuming
Yeah,
that's an example. Oh, sorry, wrong, Kevin.
yeah. I mean, I did also call this one out. I don't think I got them to agree that this is probably not something that they should try to standardize in what 1.35 or 1.36. Because honestly, it's from what I can tell, it's kind of the Wild West right now. And I don't I don't think the conformance group should try to standardize something that a lot of people are still kind of figuring out what this actually means. And also with the workload aware scheduling work going on in upstream, I think this would drastically change over time.
Yeah.
So we'll keep pushing on that one because I don't think this belongs anywhere close to something called conformance.
Yeah, at
No,
least not
it's
yet. It feels
yeah.
too undefined.
Yeah. My other concern with conformance is that we need to figure out how to write actually tests, because I haven't seen any specific proposal yet.
Working
Or
on it.
I've seen some
There's some stuff
discussions,
in
and
that repo. If you browse
and
it.
it all seems a bit unclear about how it will deploy it, how it will be delivered, how it will be maintained long term. I see experiments. I've seen I've seen different proposals. Let's say that. Nothing that has been formally proposed as this is how we want to do it. Can you please review and tell us whether that's viable from a Kubernetes perspective?
Yeah, the current sort of medium North Star is to standardize a set of tests that we can basically hand over to cloud providers or platform providers to run so that they can easily produce the attestation of various conformance criteria. Rather than right now, it's, you self-attest according to a kind of recipe, and everyone has the flexibility to do it on their own, which because we're in early days, as Kevin mentions, that's an appropriate middle ground. Like, I think if we were to take a super hard and fast stand right now, it might not. We're not ready for that as a community. So
yeah, but these tests need to be written somehow. They need to be committed somewhere, and they need to be reviewed. They need to be stable. That's something that I would like to see at some point. Yeah, before it's too late, because it's already in use and everyone thinks that it has been officially blessed as the way to do it. Yeah.
I did have I don't think this belongs in conformance, but is there discussion going on about how we could potentially standardize this among the cloud vendors and the device vendors? Because I know this is super important for NVIDIA, but I'm not sure if it's are we just taking the approach that every cloud vendor chooses their choice and then we just figure it out per cloud vendor?
So this is about the topology awareness again. Yeah. I don't know. I don't know.
Seems like that is what we're doing. That's at least what
It's what it sounds like in the PR, at least. Yeah.
Well, not in the PR. I'm not worried about the PR. I know you all were probably having discussions at this in KubeCon, especially around the topology aware scheduling. At least going in alpha, and then I'm wondering is
the workload abstraction, you mean?
Yeah, the workload abstraction and exposing this topology information on cloud vendors, is there?
Yeah.
It seems like every cloud vendor is just choosing their own approach, and we'll just have to kind of figure it out.
Yeah, I still think the format and how deep that topology representation goes is still up for debate.
But I think,
Yeah.
Kevin, to your point, the fact that everybody's doing it their own way, that is a nice, concise statement of the opportunity. That's the value opportunity from standardizing.
Yeah, I know, I agree. It's just, yeah, I guess I think we're just going to have to figure it out as we go. Because, yeah, I don't know if what AWS is doing is transferable to GCP. And sorry, I don't know what Azure's, the latest state of the world is for Azure. And that is of interest to me, but I'll probably have to figure it all out. All right, thanks, everyone.
Cool. Thanks for the time. Didn't need to take this much time for this one. So I'll circle back if there's any movements, and I'll follow up with John.
Yeah, well, we still have time. I don't think Ale is on the call. So we can start looking at
I
what he
don't,
is.
I don't see him on the call, but I chatted with him briefly about it this afternoon. And he's proposing this. So this is a already existing KEP. It was put on hold. Or is it the KEP or is this the issue? And
This is the pull request. So there
this is
is
the,
a readme.
okay,
This
yeah,
is very, yeah, let me
I
look at
the
the
KEP
file.
itself.
I'm
Oh, he is here. Okay, great.
just in time. Yeah, I'm not sure what you guys discussed.
We just pulled it up.
Just
So
starting.
yeah.
Okay, perfect. So so there was some discussion in the last cycle 135 where we wanted to land this cap. This cap is basically around having DRA attributes like the PCI bus ID be discovered by out of core projects, right? Like for example, KubeVirt. So currently the challenge KubeVirt faces is that it launches a VM inside of a pod. It's called the Virt Launcher pod. And that pod has logic to look at the PCI bus ID and render a DOM XML for the VM to run, right? And that bus ID attribute has the address, and discovering and finding that address is challenging right now for KubeVirt. So the way KubeVirt work around this challenge is it put this PCI bus ID as a status uh, as a status field in its own CRD, and then it can have access to that status inside of the like the pod where it's generating. But this is challenging again because KubeVirt also supports things like migrating VMs, and when it is migrating, it could have two pods, source and target, and two pods will have their own, PCI bus IDs because they have separate GPUs. And in that case, it becomes hard to coordinate where what is being changed. So ideally, it would be good for KubeVirt to encapsulate this information of the PCI bus ID inside of the pod or workload itself. And then once that happens, the pod starts, it has the PCI bus ID attribute, and it can generate the DOM XML. That's the context for this. I'm going to pause here if folks have questions.
Yeah, I don't remember where we got stuck with this proposal, but the first thing that stands out here with the motivation is that what people currently do is not even technically guaranteed to work reliably. The resource slices might not be there at the time when you need them. So the motivation clearly should be what we are currently doing is broken. Let's find something that works. And I don't know. I don't remember what the proposal was. Whether
Yeah.
I think
which attributes we need to pass down, because it's getting worse. Even the kubelet doesn't know the attributes. It's told to prepare certain devices, and what the array driver is being given is the pool name, device name, and resource claim. And there's no guarantee whatsoever that there is a resource slice anywhere at that point. So we would need to make a copy of relevant attributes or change what node prepare resources returns so that we can do more with it. So I don't know whether that's in
Yeah.
your current proposal, but we
No.
would need to do something like that.
So I think there are two approaches that were discussed in this proposal. The first approach has all of the challenges that you mentioned, which is that approach is specifically the way it works is kubelet has a list of attributes that it will populate as the downward API, and it will go look at those attributes from the resource slice and populate that as an environment variable, right? So that's approach number one. The approach number two was that we actually changed the plugin framework that we ship for each driver author, and that plugin framework has the code to automatically mount these attributes as CDI mounts inside of the Vert launcher pod, or inside of the pod that gets started, right? And we can phase out. We can start with default false, default equals to true, and so on and so forth. And that way, each workload will have a specific file inside of the pod to look at the attribute values when it starts up.
Yeah, I like the approach with letting the device driver or the array driver decide about which information it passes on. I like that better because the first option that you just mentioned is basically just not going to work reliably. I'd rather do the second thing, but then the question is, how do we decide which attributes? How do we decide about the format?
So
And how do you standardize on it? Yeah,
Yeah.
that's the.
Yeah. So in that case, if you look at line 229, right, that would be the standard path. 229. Yeah. That is the standard path that was proposed, and all attributes of devices will be available there to begin with.
Okay. Well, we still need to define what's in that JSON file. Yeah, but this might work.
Yeah.
So I think, sorry, Ed, would you also need to somehow discover if your driver supports this? Because at this point, it would be a fully opt-in kind of feature that a driver would have to decide it wanted to do, right?
Yes.
I guess the existence of the file implies that it's doing it.
Yeah.
Yeah.
Yeah, that is a question I had not thought of, but it is obvious that for this to work reliably on the KubeVirt side, or any consumers of this file path would need to know whether the driver has opted in or not. Yeah,
I don't see in this proposal where the kubelet plugin code gets the attributes. Well, okay, it does have them. It's combined.
It generates them.
Yeah, okay. I was just thinking, yes, that's right. So it basically has to assume that the driver is currently publishing resource slices, and that for any device that it's publishing what it currently has in the resource. Okay, I can see how that can work. Yeah.
Yeah. So that is
you could think of it as the other way to think of it is at the time of, the scheduler has allocated it. You have a name, and at the time of preparation, there's a set of attributes associated with that named device, and that's what you inject in.
Yeah.
Yes. So I think earlier question, what needs to be in the JSON file is the driver name, the claim UID, the request name, and the attributes for that.
That's the path, but what's in the file itself?
No, I think
what's the schema?
Yeah, I'm saying each one of that information has to be inside of the JSON file as well, and then the list of attributes.
Well, attributes can be strings, integers, so we basically have to specify a schema.
Yeah.
But
It sounds like
JSON
you're saying
file
it would be the same
transforms.
schema that we would have in the resource list.
Yeah, okay.
Yeah, I think that's the part where we got from where progress has not been, and this is where I thought we deferred the last time around. Oh, the JSON
So
schema.
in this proposal, the second one, it doesn't have a downward API piece at all. Like there's nothing that we would add to the resource slice at that point, or the pod itself, right?
Correct.
Yeah. It would
The
just be
idea
fully
is that
standardized on the idea that if you ask for a device and the driver for that device supports injecting all of its attributes at this file path, then your pod, when it starts up, can look at that path and consume them and do something with it.
yes.
From an API perspective, we are creating a Kubernetes API. Well, it's not a Kubernetes API, but it's a standardized API defined by Kubernetes, and we should probably do a bit more standard conform or standard ways of versioning this API. So having a kind and an API version in it. That's probably what I would call out as an API reviewer for this. Not just
rather than just raw JSON.
Not just raw JSON where we don't know how to extend it, how to rename fields, etc. So it would have to have a corresponding serializer. It's all doable, but it basically needs to be like defined like an API and versioned like it. And then we can have
And probably have a helper library around it like we do for other
yeah.
things.
Well, we get that automatically more or less by having it registered as a type that you can pull into an encoder and decoder. The whole API machinery needs to work for this file content.
Yeah.
Yeah, but I meant if we had a helper library that takes
Yeah.
a resource slice, for example, and a name of a device, and then it makes sure it generates this file and
Yes.
puts it in the right
Yeah.
path. And all
We can certainly write the helper code, and it can be fairly easy
Yeah.
for DRA drivers to support. Or it's all completely in the kubelet plugin package.
Yeah.
But then towards the applications which need to parse that, we still need a bit more content. You can't just say
They need
use
something
our
too.
helper.
Yeah.
And it needs to be something that we can version and etc. Yeah, because
Yeah,
it is an API.
I think I'm all in for that kind of encoding. It will make it easy for folks to rely on this information and read it. It's just if we can decide between approach number 1 and approach number 2, then I think I can start looking at these kind of additional details.
I think we should go for option 2. So make it local to the DRA driver, make it so that it uses information that's guaranteed to be available, and then we should be okay.
Yeah, and then in that case, the only remaining question is there a way we can signal that a driver doesn't implement this somehow?
We could standardize an attribute that's per device. No, we don't have anything saying DRA driver X has the following features. It's also a question of how reliably that information can be surfaced in the Kubernetes API control plane. It's the same as, does your kubelet support a certain feature gate? It's really hard to surface that. I think there's a whole cap about node discovery and how to be sure that something actually works on a node. And this is the same problem just for DRA drivers, which might not even be deployed consistently on all nodes.
So I think one idea that comes to my mind is as soon as this file is generated by the plugin, we can raise a condition on the claim that this file is generated. And if that condition is missing, then consumers can know that this driver doesn't support it. But I have not thought it through. I'm just spitballing right now.
Yeah, that's one way of how we can give feedback, and that would be on a case-by-case basis, which is probably the right thing, not just some general the driver is supposed to be doing this, but some actual feedback that, yes, this has happened. That may be useful. Yeah.
Okay.
Morten?
Yeah, I can follow up on this in the KEP as well, but have you thought about how this works for multi-host devices? It seems like maybe it assumes that the local controller publishes the resource slice, but I'm not sure if that's always the case. And in
That's a
that
good point.
case, we can still end up with different drivers will absorb the resource slice at different times, where they might see different data. So,
yeah, good point. And perhaps we should make it so that the local node prepare resource, it's not even node prepare resource called in the Go API, but perhaps we really should rely on the vendor to report back attributes instead of somehow tying it to what's in the resource slice.
Yeah, I think that's what we said earlier, right? It would just, in the prepare call, when it sees this device name that's come in, it knows what attributes it should associate with that, and that's what it puts on there.
Yeah, this section here is a bit light on where sorry, when I mark it, I get
It would
this.
that would need to be specified explicitly though, so it could be discussed.
Yeah.
I think that's what you're getting at.
Yeah, I think it needs to be explicit instead of this implicit thing what we just discussed, where the kubelet plugin helper has potentially a resource slice or resource slice information about devices, because as Morten just said, it might not have that. But the driver then still needs to know what it prepared, because it did just do something with actual hardware, or at least did something. So it must be able to tell more about what it did.
Yeah, it's implementing the prepare callers. It's executing the prepare call at the moment this would happen. So
Yeah, sorry, I didn't follow the last few breadcrumbs. Are we saying we do this in kubelet one level higher?
No. We do it in the helper package, but the helper package implements the gRPC call. So the kubelet plugin implements node prepare resources.
Mm-hmm.
And it does that implementation by calling some Go interface function implemented by the DRA driver author. And we can extend that local API, which is completely inside the DRA driver, so that the DRA driver code provided by the vendor returns additional information, like attributes that go into that downward API. That additional information never gets to the kubelet. It's handled entirely by the kubelet plugin package, but it needs to come from the DRA vendor code.
Yeah.
Because the kubelet plugin then would still need to make some guesses, and those guesses can fail. And it will not work for network attached devices, because then the kubelet plugin package doesn't have resource slices.
I think all you're getting at is that it can't come directly from a resource slice. It has to come from other in-memory app information that the DRA driver plugin, kubelet plugin has, so that it would inject it at the point that the prepare resources call is made.
I think that was the intention of this. It was not recorded here, so I'll take that as an action item to reflect it.
Okay.
Okay. I think then we have consensus. So option number 2 with a condition or something similar to signal, and then the processing of this and information happens in memory completely in the DRA driver.
If you do the condition variable in the resource claim status, you will run into the same problem that we have with device status, the network conditions. So you will probably need to closely look at what Antonio is doing here with publishing network interface information in a resource claim status.
Okay.
Because we have the same problem. You want to push something, you want to write from a kubelet into resource claim status, and that's tricky.
Sure. Yeah, I'll take a look. Thank you.
Yep. Okay. Well, we're almost at the end of a half hour, so.
Good Patrick, sorry, the last thing I wanted to say is that if this is so it sounds like Ali wants to propose this as a KEP that we push for 136. Do we need to add that to your list here? I don't even know if it's on this spreadsheet.
This is actually a question that has come up on the KEP, in the sense that because this is driver only option, folks were saying that we might not even need a KEP for this.
But
That's a good
think
question.
We need a KEP, especially if there's this API piece that we were talking about, like Patrick mentioned.
In a sense, it's completely outside of Kubernetes itself, but we are implementing code in it in Kubernetes. So I think we should have a KEP.
Because of the helper library, you mean?
Yes.
Yeah.
And potential API review and the status condition. Yeah, I think makes sense.
The status thing is definitely a Kubernetes API then. And how to secure that right is something that Kubernetes KEP. Yeah. Okay.
I'm sorry. So do we need to add that here then in that case?
If you want to have that condition and you want it in the resource claim status, then it needs to be in the KEP. And yes, and then your KEP proposal, your issue, we probably should just add it to the table. And also, well, we do have it in the meeting doc. Yeah, but we should add it to the table, I think. Yeah.
Sounds good. Thank you.
Okay. Thanks, everyone. And talk to you again I think we'll talk again in 2 weeks. Before Christmas then. Goodbye.
Bye.
Thanks, folks. Bye.